Okay, so this is my video for conduction, which is when heat makes physical contact, when two solids make physical contact. So there's my source of heat, and here are my two objects making physical contact. I've got a piece of copper, which is a good conductor, and on the copper I have stuck pieces of wax, which when they get hot, they will melt. So what I'm hoping is, when I hold this in the flame and get this end in the flame, the heat, the thermal energy, will move this way along the copper, and it will knock the wax off, this piece first, this piece second, and this piece third, as the heat flows from the hot end, which will be the end with the flame, to the cold end, which will be the end without the flame. So here we go, let's see. And I've got the paper there to catch the wax, because I don't want the wax to drip on the table. So here we go. So I'm heating up the one end, and there's the first one. And so the heat is flowing. There's the second one. And you can actually see the heat flowing a little bit if you take a look at the wax that's dripping there. All right, and then here comes the last one. All right, so that is the heat flowing from the right side, which is right on the flame, to the left side where the pliers are. And you can see some wax still dripping. You know, that's why I had that paper there. I'm going to set this here because I don't want it to burn my table. But that is what you need for the conduction lab. All right, so what I've got here is, this is a piece of copper that has different pieces of wax glued to it, or not glued to it, but stuck to it. And then I've got a blowtorch. And the thermal energy is gonna, when I put the blowtorch so that it touches this end of the copper, the thermal energy is gonna flow down, and each of these is gonna drop off. The one closest to the heat first, then second, then third, as the heat moves this way from the hot object to the cold object. And because these two solids are touching, the copper and the wax, this is conduction. Now, over here, I have a thermal camera, and if I bring this into the shot, you can see how the flame is actually glowing very brightly, and the piece of copper, which is right there, is black. The wax is black because I just pulled it out of the refrigerator. All right, so what I'm going to do is I'm going to stand here, and you'll be able to see the thermal energy flow from one side to the other on the thermal camera. So let me put the heat there. Okay, so now the wax is going, and you can see the thermal energy heating up. See, that one piece of wax is starting to heat up. Oh, it just fell. All right. So now I'm going to leave it here. I'll back up here. So you can see how the copper is getting hotter. It's starting to glow on the camera. This side is warmer than this side. So now the heat is reaching the middle part. And that middle piece of wax, there it goes. All right. And then it's going to continue to heat up, going towards the right, following that post-it that says hot object, cold object. That flame is the hot object, that piece of wax is the cold object, but that wax is now heating up as the flame travels across. And it is going to get to it and make it drop in just a little bit, because you can see in the thermal camera, it's flowing over to that piece of wax. All right, as the copper heats up, the heat is flowing from one side to the other side. It's flowing from the side with the hot, which is the side where the blowtorch is, to the cold, which is the side where currently the piece of wax is, but it's probably going to fall off relatively soon. I hope relatively soon, because this video is getting longer and longer. I can see in the thermal camera that it's heating up. Do I have it making contact? Now it should get really hot. Yeah, it's smoking a little bit. It's getting hot because the blowtorch is right on it. See, and there's a drip from the candle wax from the second one. And then here we go. It's getting ready to drop the third one. There it goes. All right. So the thermal energy flowed from one side to the other side. And you can see it. It's heating up on the camera. It's heating up from one side to the other side. Okay. So this is me trying to show you that different metals can conduct at different speeds. So this metal right here is copper. This one here is zinc. This one at the top is steel. This one over here is brass. And this one here is aluminum. And I'm going to hold this middle hexagon, over the flame. And I'm going to let the heat, just like you saw in the other videos, I'm going to let the heat travel down. And we're going to see which one has the wax drop off first, because that's what's on the very end, is there is a piece of wax on the end of each metal. So we're going to see which metal lets the heat flow. Remember, heat flows from the hottest part, which right now is in the middle, to the coldest part, which right now, so there's copper first. So copper is the better conductor of the 5 metals that I'm testing. All right, so copper was first. Yep, that was aluminum. Aluminum is a better conductor than the remaining 3, but not as good as copper. Copper is the best conductor so far. All right, now we have 3 left. Okay, that was brass. So now we just have steel and zinc left to see. So between the two, we're going to see which one is conducting thermal energy the best. See, and the copper one's already starting to smoke. So it was copper first, then aluminum, then brass, and now we're trying to see between steel and zinc, which one is the better conductor of thermal energy, of the heat. And remember, this is an example of conduction, because the heat going through the metal is touching the metal, and the metal is touching the wax. So this center hexagon that's glowing now is touching. There it goes. There's the steel. So that means zinc is the best insulator, the best at keeping thermal energy from flowing from one side to the other. Copper is the best conductor of thermal energy that allows the thermal energy to flow from one side to the next. All right?